Hey everybody, welcome to the only video that we have for the urinary system. This one is going to really dial into chapters 25.2 and 25.8, just because the high school portion of this class does cover a lot of the other information covered in chapters 25 and 26. Two things that I want to talk about during this video. This one will be pretty short. Is first talking about the urethra. It's the only urinary system organ that's going to be different between males and females. Remember, in females, it's going to be about 4 centimeters long. It's going to be significantly longer in males. It originates out of the bladder as part of the trigony. So you have the two ureteral openings at the base of the bladder, and then the final triangle. Think trigonometry triangles. Three. The urethral opening is going to be the third point of that triangle, or part of the trigony, but it's going to be at the base of the bladder. From there, it's going to run posterior and inferior to the pubic symphysis. Remember, that is the cartilaginous joint in between the two pubis bones of each hip. Voiding or micturition is going to be controlled by an involuntary, voluntary, or urinary sphincter, and then a voluntary urinary sphincter. And then on the female side, the urethral opening is going to be inferior to the clitoris, as well as superior to the vaginal opening, and then medial to the labia minora. That's one thing that doesn't get mentioned in the high school videos that cover the urethra. And then the RAAS stands for renin-angiotensin-aldosterone system. So you're going to have this group of cells that are lining the afferent arteriole. They're called glomerular cells. Excuse me. They're going to release a chemical called renin. That renin is going to be responsible for cutting off amino acids off of angiotensinogen, which is going to form angiotensin 1. And then angiotensin converting enzyme, or ACE, which is secreted by the lungs, is going to convert that angiotensin 1 into angiotensin 2. Angiotensin 2 is a vasoconstrictor. Basically, what that means is the blood vessels are going to get smaller, they're going to constrict. And so that's going to increase your blood pressure. It's also going to stimulate the release of aldosterone, which increases the amount of sodium ions that your kidney is pulling back into your bloodstream. And so that's because of that extra sodium that you have in your bloodstream, that's also going to pull in more water. You think back to that countercurrent system that we have. You think if there's more sodium in the blood, that's going to pull more water out of those ducts and back into the bloodstream. And so if you have more water, that means you have more stuff in your blood, in those blood vessels. And so that's also going to increase blood pressure. So this is where you may have heard people that have high blood pressure are sometimes prescribed ACE inhibitors. That's going to be a medication that is going to prevent, or at least lower, the angiotensin converting enzyme being released by those lungs, so that their blood pressure is not being pushed higher. So just those two slides. Like I said, most of this ends up being covered in the high school portion of this class. These are just a couple of things that I wanted to cover, especially when we get into some of the hormones in the